Alrighty, good evening, kiddos. Here we go. We are doing the chapter review for chapter 6, almost halfway through the book. So this starts on page 421, and the assignment is 5 through, it was like 23. Let me just quick double check. 5 through 32. Sorry, a little number dyslexic there. So what we're doing is we are, I'm just going to walk through each of these problems. So, section 6.1 is for 5 through 10. And in this, we're talking about the polygon angle sum theorem as well as exterior angles and all that good stuff. So the first one we do is number 5, and we're talking about a hexagon. So it's important to understand what it is you're being asked to do. Find the measure of an interior angle and an exterior angle of each regular polygon. Regular polygon, that's a key term. It means that it is both equilateral and equiangular. So hex means 6. So a hexagon is a 6-sided polygon. So the formula for the sum of the interior angles, so if we want to find out what one of them is, first we have to find out what all of them are together, is n minus 2 times 180. And again, what that is telling us how many triangles we could cut that hexagon up into. So 6 minus 2 times 180, n being the number of sides. See, that's where the 6 goes and just jumps over. 6 minus 2 is 4. So that's saying we could cut a hexagon into... Hey, Bella, can you go let her out, please? Cut a hexagon into 4 separate triangles. Each triangle has an interior angle or sum of interior angles of 180 degrees. And so we know that a hexagon, then, all of the angles together are going to be 720 degrees. Now, that's the total. So for the interior, we need an individual angle. So notice what we're doing here is we put up the corollary to the polygon angle sum theorem. That's n minus 2. Good night, sweetie pie. Times 180. Oh, beautiful pearly whites. Divided by n being the number of sides. And that makes sense. A regular hexagon is going to be equiangular. And notice, so we take the total there, n minus 2 times 180, and we just divide it by 6. So it's 720 divided by 6, and we get 120. That means each interior angle equals 120. Now the measure of an interior angle plus the measure of an exterior angle is 180 degrees. They are supplementary. So we go 120 plus the exterior angle equals 180. Subtract 120 from both sides, and we get 60 degrees. That's one way to do it. The other way to do it is understanding that all interior angles always are exterior angles. Exterior angles always equal 360 degrees. Okay, that's the exterior angle sum theorem. Doesn't matter whether it's a triangle, your smallest number-sided polygon, or a duodecahedron, okay, 22 sides. What does matter... Actually, I think a duodecahedron is just 12 sides. Anyway, is that because we know it's an exterior angle, because we know that all exterior angles add up to 360, because we know it's a regular polygon, so not only are all the interior angles the same, all the exterior angles are the same, we can just divide 360 by the number of sides and get the interior angle, and that's 60. So that's what that looks like. If you want, go ahead, hit pause, copy this down, and make sure you got it. I'm going to go through the next two a little bit quicker because it's the same thing. So we start off with a 16 gon. So n's going to be 16. Same exact formula. 16 minus 2 times 180 gives us 14 times 180, or 2,520. That is the sum of all the angles. To get the individual angle, we divide by 16, that's the number of sides, and we get 157.5. Totally legitimate to have a decimal there. So, That's the interior angle. Exterior angle, we're just going to go 360 divided by 16, plug that into the calculator, and we get 22.5. Notice we add those together, get 180, quick check, make sure they're supplementary, good to go. On to number 7. Pentagon, pent means 5. So interior, 5 minus 2 times 180. 3 times 180, pentagon, 3 interior triangles. Each interior triangle, 180 degrees. That means 540 degrees inside a pentagon. We then divide by 5, and we get 108 degrees. So in a pentagon, in a regular pentagon, each interior angle will measure 108 degrees. Each exterior angle, 360, the sum of the exterior angles. 5, how many exterior angles we have? We get 72 degrees. And then number 8, what is the sum of the exterior angles for each polygon? In exercises 5 through 7, 360. Always, doesn't matter how many sides we have. You should be able to answer that with even looking at 5 through 7. What is the sum of the exterior angles? Boom, 360. Okay. And again, if we wanted to, we could quick look at these two. Double check, 72 plus 108, 180. Supplementary angles. 360, that's the circle. Even if we put a 16 gon in there, notice all the way around 360. When you think exterior angles, go back, watch the video, think and the angle and this trip around the triangle. Okay, number 9. Now number 9 is a pentagon. Okay, look at number 9, count the sides. 5, pentagon. Now we already know that the interior angles equals 540. Why? Because we just did it. Number 7. So we know that if we add up all of the angles in there, they got to equal 180. They don't have to equal 180. They actually have to equal 540. There we go. So 119 plus 83 plus 89 plus 90. Plug that into your calculator. You get 381 plus x equals 540. You're then just going to subtract 381 from both sides, and you're going to get that x equals 159 degrees. Number 10, at any time, if something doesn't make sense to you, go back, rewind it. Watch that problem again. If it references something earlier and you don't understand what it references, go back and reference that. Bella, can you let the dogs in, please? So, number 10. Quadrilateral. 4 sides. Okay? So, in order to figure out what the sums are, I'm going to do a quick little computation there. 4 minus 2 times 180. That gives us 2 times 180. Or 360. So we know it's 360. So what we do is we have 122, Z, 79, and a right angle. Right angles are 90. So that gives us 291 degrees plus Z has to equal 360. We're going to subtract 291 from both sides, and we get Z equals 69 degrees. Moving on to number 11. That's Bella. She feels, that's my 9-year-old, she feels that this math is stupid.
Yes.
Okay. Now go lay down. You need to get to sleep. Okay. So 11, we're trying to find the measure of the numbered angles. So I'm actually going to quick draw this here. Okay. So that is what we're given. And we need to figure out what the measure of 1, 2, or 3 is. Now, we're told this is a parallelogram. Parallelogram. Opposite sides, opposite angles, congruent. Consecutive angles, supplementary. Opposite sides, parallel. Okay, again, opposite sides, parallel and congruent. Opposite angles, congruent. Consecutive angles, supplementary. So we're going to start off, we're going to look at 3 and 99. Hey, opposite angles. Measure of angle 3 equals 99. Third of the way there. We also know that those top and bottom lines are parallel. Well, how do we know that? It's a parallelogram. If we extend that side one a little bit, we see that those two parallel lines in that diagonal actually forms a transversal. And that means that that 38 degree and that angle number 1 are actually alternate interior angles. We go all the way back, I think that was chapter 2 or 3. Alternate interior, when two parallel lines crossed by a transversal, alternate interior angles are congruent. Okay, so we know that, it looks like I put that down, alternate interior angles are congruent. So the measure of angle 1 equals 38. And there are two different ways to do this, but I'm going to go that the measure of angle 1 plus the measure of angle 2 plus 99 equals 180. How do I know that? Because it's a triangle. See? Right there in red. Triangle. Interior angles of a triangle, 180. So we already know that 99 we got there. We just dropped that 38 in. 38 plus 99 plus the measure of angle 2 equals 180. And we get 137 plus the measure of angle 2 equals 180. Subtract 137 from both sides, and we get the measure of angle 2 equals 43. The other way to do this would be to understand that these two sets of consecutive angles right there that I just circled are also supplementary. What does that mean? Supplementary means that they add up to 180 degrees. Okay, moving on, number 12. 12, a little bit easier. Again, here what we need to realize is when we went back, we said parallelograms, opposite angles, congruent, consecutive angles, supplementary. So we're given 4 angles in a parallelogram. We're only being told what one of them is, and that's 79. So right away we know opposite angles are congruent. Why? This is a parallelogram. So measure of angle 2 equals 79 degrees. We also know that 1 plus 79, hey, those are consecutive angles, so those are going to be supplementary. Subtract 79 from both sides, and measure of angle 1 equals 101. Measure of angle 3 is going to be congruent to the measure of angle 1. Why? Because they're opposite angles. Also, 3 and 79 are also consecutive angles, so it's also supplementary. Bella, go lay down, honey. I'm going up to number 32, and we're on 12. Okay? So measure of angle 3 equals 101. Okay, and here is number 13, lucky number 13. So this is, hit a coffee. Okay, so this takes a little bit more work. That's what we're given. We need to find 1, 3, and 2. So we can start off and go, okay, well, I know that 63 plus whatever that little angle is there equals 180 degrees. So I know that that X angle right there, no, you need to go lay down, is 117 degrees. Okay? So we'll write that down, 117. Now we go back and we look up at 11 and we go, hold on, 38 and 1, 1 and 37. Again, alternate interior angles. Measure of angle 1 equals 37. So, where to now? Well, we know that 1 plus 3, so we know that 63 is going to be an exterior angle to 37 and 2. Okay, remember, an exterior angle of a triangle is equal to the sum of the two remote interior angles. Check 37, we get the measure of angle 2 equals 26. So, because 2 and 3 are also alternate interior angles, we know that 3 as well is 26. The other way to do that would be, that 117 plus 1 plus 3 equals 180 degrees, again, because it's a triangle. See this triangle right here? And sound effects are professional. I am available for private hire. 117 plus 37 plus the measure of angle 3 equals 180. We go through that, and hey, check it out. We get the exact same answer. Okay, 2 ways to skin a cat. On to number 14. Okay, so 14 requires you to kind of understand the special properties of parallelograms. We know that all parallelograms, the diagonals bisect each other. So here we have that 90-degree thing in the middle, which means that all four of those are going to be 90 degrees. Right? We know that those are equal, so they're all four equal. We can also know that if the diagonals perpendicular bisect each other, which these do, that it is a rhombus. This is a rectangle and a rhombus, which we call a square. We know that in a rhombus, the diagonals bisect opposite angles. We know this is a square. How do we know that? Because we know it's a rectangle, because the diagonals are congruent. So if the diagonals are congruent, then it's a rectangle. Diagonals bisect or perpendicular to each other, it's a rhombus. Rectangle and a rhombus, square. Okay, so we know that those two together are 90. We know that rhombus splits opposite angles. So that means 1, 2, and 3 are all 45 degrees. There you go. See, 45 degrees, all three of them. Neat little thing there. Okay, 10. So now we're going to go on to number 15. Now, number 15 and 16 are almost identical problems. So what I'm going to do is I'm going to quick sketch 15 for you. 15 is a parallelogram. Remember, parallelogram, opposite sides, parallel and congruent. So we're given that it's ABCD. We're given that AB is 2y, BC, y plus 3, CD, 5x minus 1, and AD, 2x plus 4. So we're looking at the opposite angles here, and we know that they're congruent to each other. So we're going to go ahead and just write out those two equations. Y plus 3 equals 2x plus 4, and 2y equals 5x plus 1. So what I want to do here now is just treat this like a standard algebra problem, wherein you're looking at the systems of equations. So we look over on the right-hand side, and we see that y kind of floating by itself, just begging to be isolated. So we're going to go ahead, grant its wish, and we get y equals 2x minus 1. Now that we have y equals 2x minus 1, we can go and plug it over into the y on the other equation. Remember, substitution. Substitution in systems of equations. So we go 2 times 2x minus 1. It's actually a plus 1, and I'll fix it in just a second. There we go. And so I'm going to subtract 4x from both sides, and I get 2 equals x minus 1. Add 1. Bella, can you get the dog's food, please? And I get x equals 3. Actually, Bella, don't worry about it. Go lay down. I'll get him food. Girls, go to bed. So now we're going to take that 3, plug it back in. We know that x equals 3. So now we can solve for y. 2y equals 15 minus 1. 2y equals 14 divided by 2, and we get y equals 7. Okay, so now we can just double check. We can, if you plug them in, up top, 7 plus 3, 10. Y, x is 3, 2 times 3 is 6, 6 plus 4, 10. It all works out. 11, same exact issue. Now with 11, or with 16, we're on screenshot 11. On 16, I'm actually, because I know that AB is opposite CD and BC is opposite DA, just going to go ahead and write out those equations. 3x equals y plus 1, 2y plus 1 equals 7x minus 3. Now again, I'm looking for that kind of lone wolf, and that's that y over there. That y is the only one by itself. Subtract 1 from both sides. I get y equals 3x minus 1. I now take that 3x minus 1, plug it into the other y. 2 times 3x minus 1 plus 1 equals 7x minus 3. 6x minus 2 plus 1 equals 7x minus 3. 6x minus 1 equals 7x minus 3. Combine like terms, adding 3 to both sides, and then subtracting 6x from both sides. And we get 2 equals x. Plug that 2 back up top into the x, and we get y equals 3 times 2 minus 1. Y equals 6 minus 1. Y equals 1, 5. So we have x equals 2, y equals 5. Notice if we plug those in, we get 11 equals 11. And so that's how we check our work. We go back, we plug back in our variables, make sure that they give us the answers we're expecting. In this case, the answers we're expecting are that opposite sides are congruent. So, on to number 17. So 17, we're trying to figure out whether or not we have enough information to determine whether or not that is a special quadrilateral and must be a parallelogram. So here we have that vertical angles are congruent. Whoa, that was... Oh, I went... Okay. Here all we have are that vertical angles are congruent. Well, vertical angles are always congruent. Doesn't matter whether it's a parallelogram or just two lines floating out in space. So no, those angles are congruent simply because the lines cross. Nothing special about them. They're not right angles. They don't bisect each other that we know of, anything. No information for a parallelogram. Moving on to number 18. We have two diagonals that bisect each other. How do we know they bisect? See those little markings right there? That means this right here and this right here are equal. So if one line gets the other one cut into two equal parts, it's bisecting. Bisecting diagonals, that's a parallelogram. So that would be a big old yes. Okay, so now for 18 and 19, we're saying what does x have to be in order for this to be a parallelogram? So what we're doing is we're looking at this and we're going, if this is a parallelogram, then we know that opposite angles are congruent. Okay? So now we're looking for that lone wolf and we don't see it, right? Over on the top left, we have 4x equals 4y plus 4. Top right, we got 3y minus 20 equals 2x plus 6. So we have to get a little bit creative. We look up top left and we go, hey, all of those numbers are divisible by 4. So that's what we're going to do. We're going to divide all of them by 4. And we get x equals y plus 4. Hey, or y plus 1. It's 4 divided by 4. It's not 4, but 1. So we can now take that, plug it in for that x over there. And then we just run that through. 3y minus 20 equals 2 times y plus 1 plus 6. And I jump ahead a little bit. But we can just go there. So, I'm picking up right there. 3y minus 20 equals 2y plus 2 plus 6. 6 plus 2 is 8, so we have 3y minus 20 equals 2y plus 8. And then I'm going to add 20 to both sides. We get 3y plus 2y plus 3y equals 2y plus 28. Subtract 2y from both sides, and we get y equals 28. At first, you might go, hey, that's a big number, and you're right, it is. And it's going to suck to sit there and do that multiplication. But that's what your math told you, so you trust it, and you move forward. Plug that 28 back up, and you get x equals 28 plus 1, or y equals 29. It's actually x equals 29. So what we're going to do is we're going to double check our work. We know that consecutive angles in a parallelogram have to be supplementary. So if we plug in 29 and 28, notice we get 4 times 29 is 116. 2 times 29 is 58. Plus 6 is 64. We add those together and we get 180. Now let's try it with the 9s, with 28. 3y minus 28, that gives us 84 minus 20, or 64. 4 times 28 plus 4 is going to give us 116. Check it out. 84, 116, both sides. So we're good to go. On to number 20. 20, same general idea. It's really kind of the same problem, except instead of dealing with the angles, we're dealing with diagonals. And we know that because it's a parallelogram, that the diagonals bisect each other. That means they cut each other in half, which means that 3y minus 3 equals 3x, and that 4x minus 2 equals 3y minus 1. Now again, no lone wolf here. Nothing we can sit there and kind of look at and go, hey, that's going to be separated really easily. But again, just like the last problem, we look over to the left and we see 3x, 3y, 3. Boom. We can go ahead and divide all three of those by 3. We're going to get x equals y minus 1. Hey, that looks familiar. So we're going to now take that and we're going to plug it back in on the other side. Okay? So we get 4 times y minus 1 minus 2 equals 3y minus 1. 4y minus 4 minus 2 equals 3y minus 1. 4y minus 6 equals 3 minus 1. Y equals 5. What I did there was I just jumped ahead, but we go over, plug that y back in. 5 minus 1 is 4. And then I just kind of drew a little diagram of the diagonals, and you can see that going this way, right here, they both equal 14, and going the other way, they both equal 12. So we did, in fact, by finding that x equals 4 and y equals 5, we're able to show that they bisect each other. Moving on. Okay, so now we're down into properties of rhombuses, rectangles, and squares. Remember so here we are. We're going to start off, and we got a rhombus. Rhombus, how do we know it's a rhombus? Equal sides. It's kind of the definition of a rhombus. It is a quadrilateral, which is equilateral. An equilateral quadrilateral is a rhombus. So, what do we know about a rhombus? Well, we know that a rhombus, the diagonals do two things. They are perpendicular to each other, and they bisect opposite angles. So if we know that 32 is half an angle, then we know that okay, so whoa. So we know that 3 is 90 degrees. Right? Why do we know that 3 is 90 degrees? Because, not just because I said so, but because it's right. Wow, I'm not doing well today. Okay. Let me get back to where I was. So I know that because the diagonals are perpendicular to each other, we know that angle 3 is going to be 90 degrees. We also know that 2, because opposite angles are equal and they bisect each other, 2 is going to equal 32 as well. Also, 2 and 32 are, again, alternate interior angles. So that leaves us with number 1. We know that 90 plus 32, so we got 90 right here, 32 right there, plus 1 equals 180. So run that through the math, and we get the measure of angle 1 equals 58 degrees. And that checks because if we doubled up that angle and that angle right there, we get 64. That's 32 times 2. If this is 30, if this is 32, this is 32, rhombus, but cut opposite angles in half. So if this is 58. This also is 58. So if we add all these together, that's two consecutive angles. They should be supplementary. 64, 116 gives us 180. Okay, so moving on. So now we're looking at problem number 22. This is a rectangle. How do we know it's a rectangle? Well, because we see that right angle right here. One right angle means four right angles. Why? Because in order to be consecutive sides are supplementary. What's supplementary to a 90-degree angle? Why? Another 90-degree angle. And then opposite, we have another 90-degree angle. So, it's a rectangle. So another measure of angle 1, okay, is going to be supplementary to that 56. So we get 1 equals 124. Now what I'm going to do is I'm going to quick draw a triangle here. And what I'm going to show you is that because it's a rectangle, we know that this side and this side are the same. And that's in a rectangle, diagonals are congruent. So what I did is I basically took this triangle right here and drew it down here. See, we got that 56 up top, and then we know that it's an isosceles triangle. So the isosceles triangle, remember, two equal sides, two equal base angles. So we get 56 plus 2x equals 180. Run that through, and we get x equals 62. 62 is going to be angle 3. And we know that 2 and 3 add up to 90 degrees. So we go 62 minus, or 90 minus 62. Measure of angle 2 equals 28. So we got there, there, and there. Okay? So that is number 22. Again, if any of this doesn't make sense, if you feel like I'm going too fast, we are 32 minutes into it, and I know that's some time, but go back, watch it again and again and again until it makes sense. If it still doesn't make sense, drop me a note at the bottom. So this doesn't make sense. I'm looking at this problem. I've watched it X number of times. Okay. 23 through 28. What is important to understand is that all of these are dealing with the hierarchy of parallelograms right here. So we remember, we start up here. If it's true for a parallelogram, it's true for all of these. Okay? If it's true for a rectangle, true for a square. So if it's a square, then it's a rectangle and it's a parallelogram. So the first one says a rhombus is a square. Is a rhombus a square? Well, it can be. It can also not be. So we go sometimes. Next, a square is a rectangle. See how a square is underneath a rectangle? That means all squares are rectangles. So we go always. 25. A rhombus is a rectangle. Can a rhombus be a rectangle? Sure, if it's a square. A square is a rhombus, which is a rectangle. Or a rectangle that's a rhombus. So we're going to go sometimes for number 25. 26. The diagonals of a parallelogram are perpendicular. So the rule for a parallelogram is that the diagonals bisect each other. Anything above and beyond that makes it a special type. A rhombus, it's the old one, I know, honey. It's still pretty cute.
No, it's a new one.
No, that's Haley Mills. It's the old one.
No, it's not the one with the girls.
I know, honey. I know. My daughter's having a fit because they Parent Trap on Netflix is the Haley Mills version, not the one with Lindsay Lohan. Okay, back to math. 26, the diagonals of a parallelogram are perpendicular. Okay, what type of parallelogram has perpendicular? And that would be a rhombus. Rhombus's diagonals are perpendicular. Again, not all parallelogram are rhombi, but all rhombi are parallelograms. So we're going to go sometimes there. .27, the diagonals of a parallelogram are congruent. This is kind of the flip of 26, because instead of a rhombus, we're now talking about rectangles. Rectangles have congruent diagonals. All rectangles are parallelograms, not all parallelograms are rectangles. So we go sometimes. And finally, we go opposite angles of a parallelogram are congruent. That is always, always, always true. So we go always, and that is 23 through 28. Again, you need to know the rules here. Okay? So, moving on to 29. Almost done. Got 4 left. So we're saying, can you conclude that the parallelogram is a rhombus, rectangle, or square? So we know that these are parallelograms, right? And all we're being told in this first one on 29 is that those two angles are congruent. So we have a diagonal here, and we have alternate interior angles are congruent. Well, duh. They're alternate interior angles. We have parallel lines. Alternate interior angles are congruent. So we cannot conclude that it is a rhombus, rectangle, or square. Could it be? Yes. It absolutely could be, but we just don't have enough information. 30. Okay, so we have one right angle. So it's important to understand with one right angle, it means that they're all right angles. We went over that a little bit earlier. That was back on, I believe, number 22. So if that doesn't make sense, go, oops, jumped. So here we have, so all right angles. So we know it's at least a rectangle. We also know that two consecutive sides are the same. Well, if the consecutive sides are the same, then that means all 4 sides are the same. Because consecutive, we know in a parallelogram that opposite angles are the same. So, or opposite sides are congruent. So if 2 sets of opposite sides are congruent, we have 4 congruent sides. So this gives us equilateral and equiangular, or a square. Okay? Now, on to 31 and 32. For what value of x is the figure a parallelogram, or the given parallelogram? So for the first one, I'm not going to draw the whole figure, but we're being asked to find whether or not 31, or when is 31 a rhombus. Now, we go back and we remember rhombuses, oh right, the diagonals bisect opposite angles. So for this to be true, 5x minus 30 equals 3x plus 6. We solve for x, and we get 2x equals 36, or x equals 18. Okay, so if x equals 18, then it's a rhombus. X equals anything else, it's not. And finally, rectangle. Rectangles have congruent diagonals, which means that because it's a parallelogram, okay, diagonals bisect each other. So if we have a rectangle and the diagonals are congruent, then when they cut each other in half, we have 4 equal pieces, which means that if one of those pieces is 2x minus 1, one of those pieces is x plus 3, that we can just set them equal to each other and solve. 2x minus 1 equals x plus 3. Subtract x from both sides, we get x minus 1 equals 3. Add 1, x equals 4. And that is your review. If you have any questions, be ready for them tomorrow. Okay? Have a wonderful evening, everybody. I hope this helped. Test on Wednesday. Don't forget. See you then.